Hi there, and welcome to this lesson on Pure Mathematics 1. We're on Chapter 1, and we're up to 1.6, Rationalizing denominators. Now, rationalizing denominators, what on earth does that mean? If you have a fraction involving a surd, so a square root, it is sometimes helpful to remove all the surds, all the square roots from the denominator, the bottom of the fraction. If you do that, it looks neater. It's easy to understand what you have as the answer, and it can also make further work easier to do. That's, I think, the main reasons for doing it. So, for example, if you have something like 5 over root 3, where the root's on the bottom, 1 over 2 minus root 5, 8 over 7 plus 4 root 3, any fraction where there's a square root on the bottom of the fraction, there's a technique, or a couple of techniques, for managing to move them off the bottom so that the bottom is a rational number, which is why it's called rationalizing the denominator. The method for removing the surd from the denominator involves multiplying both the top and the bottom of the fraction by the same expression. If you multiply the top and bottom of the fraction by the same thing, you haven't changed the fraction. It's exactly the same method as you'd use in simplifying a fraction. Okay, rationalizing denominators, case 1. The first case is if you have a fraction of the form, just a single number, a, and a single root on the bottom, root b. What you do is you multiply the top of the fraction by root b, and you multiply the bottom of the fraction by root b. You're just multiplying by 1, so you won't have changed the fraction. For example, rationalize the denominator of the fraction 5 over the square root of 3. I'll let you have a go at doing this yourself. Have a quick go, pause the video, and then start it again when you are done. Okay, so we had to multiply by whatever the root is on the bottom of the fraction, top and bottom. So in this instance, it means we need to multiply the top by root 3, we need to multiply the bottom by root 3. When you do that, on the top, you will get 5 root 3, and then it becomes clear why we've done it. On the bottom, you get root 3 times root 3. Root 3 times root 3 is just 3. So the square root vanishes. You've got a whole number in this case on the bottom. The second case is if you have a fraction of the form, a number on the top, and then a number plus a square root or a number minus a square root on the bottom of the fraction. Now, if that's the case, you multiply by whatever you've got on the bottom, but swapping the sign. So if you had a plus on the bottom, you'd swap it to a minus. If you had a minus on the bottom, you'd swap it to a plus. I'll let you have a go again. So one example, rationalize the denominator of this fraction. You've got 5 over 4 plus root 3. Just to get you started, in case that was all a bit confusing, you're going to have to multiply the top by 4 minus root 3. You're going to have to multiply the bottom by the same thing, 4 minus root 3. Pause the video, start it again when you're ready. Okay, so as we said, you've got to multiply the top by 4 minus root 3, you've got to multiply the bottom by 4 minus root 3. Exactly the same thing as you've got on the bottom, just swap the sign. Now on the top, you'll get 5 times 4 into minus root 3, haven't done very much there. And on the bottom, writing it in brackets, you've got 4 plus root 3 times 4 minus root 3. We haven't done very much there, just tidied it up really. Now we'll do the multiplying out. 5 fours are 20. 5 times root 3 is minus 5 root 3. 4 fours are 16. 4 times the minus root 3 gives you minus 4 root 3. And then 4 times the plus root 3 gives you plus 4 root 3. That's the reason for what we've done there. Root 3 times root 3 gives us 3. There are 2 bits that involve a square root, but one is plus, one is minus. Aside from that, they're identical. They cancel each other out. That is what always happens with this method. It's why you do this. It's the same idea as you have in the difference of 2 squares. So on the top, we've got 20 minus 5 root 3. On the bottom, we've got 13. And yes, I wasn't sure. You could leave it as that, or you could split it up into 2 bits, the 20 over 13 and the minus 5 over 13. That's probably neater, actually, just leaving it as it is. Okay, a set of 5 examples. Those type of questions, I think the last one may confuse you a little, but hopefully the first four are very similar to the two we've just done. Pause the video, have a go at them, come back when you're ready. Okay, we'll go through these together. So the first one's just 7 over root 11. You multiply the top and the bottom by root 11. When you do that, on the top you get 7 root 11. On the bottom, root 11 times root 11 is just 11. That's it, finished. We've got rid of the root from the bottom. We've rationalized the denominator. Second question, 1 over 5 plus root 3. To rationalize the denominator, we multiply the top and the bottom by the same thing, but with a minus instead of a plus. 5 minus root 3 over 5 minus root 3. On the top, that gives us that. We'll have those two brackets multiplied together. Multiplying out the brackets on the bottom, we get 1 minus, 1 plus. They'll cancel each other out. 25 take away the 3 gives us 22. So 5 minus root 3 over 22. The third example is similar. The top is a little bit more complicated, so you'll have a bit more work to do. But the idea is the same. We've got 3 minus root 5 on the bottom. That means we need to multiply the top and the bottom by 3 plus root 5. Same expression, but swapping the sign. Now, on the top, we'll get 4 times 3 is 12. 4 times root 5 is that. 3 times root 7 is that. Root 5 times root 7. You just do 5 7 to 35 and keep it in the square root. On the bottom, 3 3s are 9. You get a plus 3 root 5 and a minus 3 root 5. That's a mistake there. That should say root 5, minus 3 root 5. And then you'll get a minus 5 when you multiply the two roots together. These cancel. That leaves you with 9 minus 5 on the bottom, which is 4. Looking at the top, you might hope that you can tidy it up, but I'm afraid you can't. It is just a bit of a mess. The fourth question, we've got root 5 minus root 3 on the bottom, so we need to multiply by root 5 plus root 3 over root 5 plus root 3. When we do that, we'll get 5. Root 3 times root 5, you just do 3 5s of 15 inside the square root, and 3 5s of 15 inside the square root there. Root 3 times root 3 is plus 3. On the bottom, the root 5s multiply to give us 5. We get a plus root 3 and a minus root 15, and then minus root 3 times root 3 becomes minus 3. As always, those two terms cancel. On the top, it simplifies to 8 plus 2 root 15. On the bottom, 5 take away 3 is 2. Well, we can divide by 2, so that does simplify even more, and that'll give us 4 plus root 15. That brings us to the last example, which is a tad more confusing. So you've got root 2 over 1 plus root 5 squared. I think the first thing I do is write this bit down on the left. So the 1 plus root 5 squared means 1 plus root 5 times by 1 plus root 5. The method for this is to times by 1 minus root 5, but you're going to have to times by 1 minus root 5 twice because the 1 plus root 5 turns up twice. So what's going to happen on the next line on the bottom is we'll be doing this 1 plus root 5 times by this 1 minus root 5. And we'll be doing this 1 plus root 5 times by this 1 minus root 5. On the top, we've multiplied out the brackets here. 1 times 1 is 1. We've got 2 lots of minus root 5, so you get minus 2 root 5. And the root 5 times the root 5 gives us 5. Now on the bottom, when we do the first bracket here times by the first bracket there, we get 1 times 1 is 1. The two middle terms cancel each other out. Root 5 times minus root 5 is 5. Same thing happens again when we do the second bracket here times by the second bracket there. Moving on from there, multiplying out the brackets on the top, we've got root 2 minus 2 root 10. 2 times the 5 gives us the root 10 there, and plus 5 root 2. On the bottom, we've got minus 4 times minus 4. Minus 4 times minus 4 is plus 16. And, oh, that does tidy up a bit because we've got 5 root 2 plus another root 2. So we've got 6 root 2 minus 2 root 10 over 16. And these are all even, so we could halve them all. And that would give us 3 root 2 minus the 1 root 10 divided by 8. And I think that's as far as it goes. I don't think you can simplify that anymore. Which brings us to the end of the lesson. And if you have the textbook, then turn to page 15. Have a go at exercise 1F. And once you've done that, you have reached the end of chapter 1. So also, you should attempt the review chapter at the end of chapter 1. That is the end of the lesson. Thank you very much for listening. And